Okay, next up we're looking for the Taylor series. For the ln of 1 plus x. So in order to find it, we need to remember the Taylor series formula, which is just the summation from n is equal to 0 to infinity of the function. You take the derivative to n, evaluated at a, over n factorial multiplied by x minus a to the power of n. Okay, and so we know that f of x, let's start by finding, sorry about that, ln u. So the Taylor series for ln of x, and then or ln of u, and then you just plug in the u as 1 plus x in your formula that you've derived, and then that would be your final answer. And so so I'll read it at ln x. So f of x is equal to ln x. We know that the first derivative is going to be equal to 1 over 1 plus x. The second derivative is going to be negative 1 over 1 plus x squared. The third derivative is going to be 2 over 1 plus x cubed. The fourth derivative is going to be equal to negative 6 over x plus 1 to the power of 4. And so let's go ahead and write out our summation. So it'll become so that would look like that, evaluated at a over 0 factorial, negative a, sorry, x minus 0 to the power of 0 plus the first derivative, evaluated at a over 1 factorial, x minus 1 to the power of 1, and you just go on like that, adding up the n values. And so we're just going to go until the fourth n value because we have the derivative until that number. You can keep going, but you can develop a sense of the pattern if you just have a few of them. And so if you put in what we have, it'll become the 0th derivative, and so that's just going to be ln, evaluated at a, x minus 0 to the power of 0 is 1, 0 factorial is 1, so that will be left like that. The first derivative is 1 over 1 plus x, but remember it's evaluated at a, so the x will become 1 over 1 plus a over 1 factorial, so that's just going to be 1 over 1. Multiplied by x minus 1 to the power of 1. Next up, we have the second derivative. So that is negative 1 evaluated at a over 1 plus a squared into x minus 2 squared plus, so 0, 1, 2, the third derivative. So 2 over 1 plus a, sorry, let's not forget about the factorial. So that's supposed to be over 2 factorial. 1 plus a cubed. Yeah, into x minus 3 cubed plus, and just keep going like that. We can include the fourth one if we'd like. So this would become minus 6 over 1 plus a to the power of 4 multiplied by x minus 4 to the power of 4 over 4 factorial. And so now we'd like to look at what we have here and try and see if we can see a pattern that we can just again represent with a summation. And the pattern that you actually pick up would be, let's first take out this ln of A. And then let's have the rest of the terms. And with the rest of the terms, you can actually begin to see a pattern if we start at n to the power of 1. Sorry, n is equal to 1. So it'll become ln A plus the summation from n is equal to 1 to infinity of -1 to the power of n plus 1. So the -1 there is because of the alternating pattern in the sign. So positive, negative. This way, when you start at 1, this would be -1 squared, so positive, and then it'll become -1 to the power of 3, so negative, and so on and so forth. And then we have over n multiplied by x minus a over a plus 1 all to the power of n. And so the reasoning for it being just over n and not factorial is because 3 factorial is going to be 3 by 2. The 2 will cancel out with this one in the numerator. 4 factorial is going to be 4 by 3 by 2. The 3 by 2 is going to cancel out with this 6, and so on and so forth. So it'll cancel out the fact that it's factorial because of these coefficients that we have here. And so this is going to be your final answer for ln of x. Right? And so that means that the ln of x plus 1 is going to be the ln of a plus 1 plus the summation from n is equal to 1 to infinity of -1 to the power of n plus 1 over n. And then we're going to put in x plus 1 as our x minus a over a plus 1. Sorry, this is going to remain ln of a because it doesn't have an x value in it. And then this is all to the power of n, as we see here, which means that the ln of x plus 1 is going to be ln a plus the summation from n is equal to 1 to infinity. The -1 remains the same over n. X plus 1 minus a is just going to stay x plus 1 minus a because we can't simplify it further. In the scenario where you can, and like it's x plus x squared, then we can simplify that. But in this case, we can't. So we just leave it like that. And that's going to be the final answer.